This conference will now be recorded.
Great. Well, hello, everyone. I hope everyone is having a great morning and great afternoon if you're here on the East Coast. Thank you to everyone on the West Coast joining bright and early at 9 o'clock in the morning. So this afternoon, we are going to be hearing from the WebCOOS team about how web cameras are used for coastal flood insights. We have a whole panel of speakers that I'm super excited to get started. So I will just get right into it. Next slide. As many of you know, SECOORA is the coastal ocean observing system for the Southeast. We cover North Carolina, South Carolina, Georgia, and Florida. And our mission is to collect data and create tools that support healthy human populations, coastal economies, and a healthy, sustainable environment. We are one of 11 of the regional coastal observing systems that make up the NOAA-led U.S. Integrated Ocean Observing System, or USIUS. Next slide. And here are some pictures of some projects that we're involved in. Obviously, this does not cover all of them, but it's nice to provide some insight into what we do. We want to observe, understand, and increase awareness of our coastal ocean, supporting community, economic, and ecosystem resilience through strong partnerships, like all of the partnerships that you're going to be hearing from today with all of the different institutions we have coming together for this webinar. Next slide. So as I mentioned a minute ago, which you might have missed, all of our webinars are available on the SECOORA website, which is just secoora.org. We have an entire page dedicated to our Coastal Observing in Your Community webinar series, which we try to do about 6 a year. Sometimes we do more, sometimes we do less. And the recordings are available on our YouTube channel, which you can access through this page. Next slide.
All right, thanks, Emily. So with that, we will move on to the main presentation here today about WebCOOS and water levels and using web cameras for coastal flooding insights. The whole WebCOOS project team, or many of us, will be speaking. I'm Theo Yas, the WebCOOS Project Manager with SECOORA, and I'll be talking for just a few minutes here about the project overall and some background before different folks talk more in depth about using web cameras for coastal flood monitoring. So first of all, WebCOOS, or the Webcam Coastal Observation System, is a network of web cameras that are low-cost coastal observing platforms transforming how community environmental monitoring is conducted. Web cameras can address significant gaps in the ability to monitor and accurately forecast weather, ocean, ecological, and public health hazards. WebCOOS is a community-supported, low-cost webcam coastal observing network, which provides imagery and tools for scientists, communities, and local coastal managers to make decisions. We started off in the Southeast in 2017 as the WebCat project, just a pilot project in SECOORA region. Then from 2020 to 2023, we're in the launching WebCOOS phase, in which we expanded the number of cameras both in the Southeast and a few in other parts of the country, and also worked to develop applications and algorithms using the imagery. And now we are in the national WebCOOS phase, where we are expanding across all the IU's regions. You can see cameras here in Alaska, California, Hawaii, the Northeast, the Gulf Coast, Great Lakes, all across the country, working to add even more. The main applications of WebCOOS include shoreline change, beach usage, counting seals or birds, detecting rip currents, and flood monitoring. And in this presentation, we're going to focus on the flood monitoring aspect of WebCOOS. So with that, I'll pass it over to Matt Conlon to talk more about coastal flooding. Matt, go ahead.
Yeah, thanks, Theo. Hi, everyone. My name is Matt Conlon. I'm a oceanographer with the little consulting company called Ocean Associates Inc. But I'm on contract with NOAA Co-ops. So I have the opportunity to work with Greg, who's a federal employee with Co-ops, and has been really integral to the WebCOOS project from the start. And so I'll sort of be presenting on our behalf today. Next slide, Theo. So I'll start with kind of a broad overview, sort of what we're working on, which kind of I think ties into sort of the more specific things that others will get into in a bit. But as I think many of you are probably aware, the NOAA's Center for Operational Oceanographic Products and Services, co-ops, deploys and maintains tons and tons of tide gauges all around the country. And some of the WebCOOS cameras that have already been deployed, and hopefully more that will be deployed in the future, are co-located or at least very closely located with some of these tide gauges. So the pictures that you see on the left here, those are from the Charleston and Lawn Station and the Beaufort tide gauge as well. And so, I think this kind of gives us the opportunity, right, to take the really rich quantitative water level information that the tide gauges give us and merge them with this really nice visual information that we get from cameras to really get a sense of on the ground, what do these water level data points that we're seeing in our graphs, what do they actually look like, if we were standing on the ground looking at them. And so that's kind of the impetus and the overview of what Greg and I have been working on for this specific aspect. So Theo, if you go to the next slide, we've developed a couple software packages. I apologize to any non-coders in the room to throw a few lines of code up here, but basically we developed a couple packages to sort of make it easier in an object-oriented programming language like Python, which a lot of people use, to access WebCOOS data. So that's this Pi WebCOOS client that you see in the top. WebCOOS, it has an API, but it's pretty low level. It's kind of a command line type tool. So we developed kind of a Python wrapper around it so that if anyone's familiar with using Python, you can sort of go in and fetch WebCOOS data with that. And that sort of allowed us to build this more complex software package on top of that, which you're seeing on the bottom, which I've very creatively named Enlon WebCOOS Synchronizer. And this is really just a software package that kind of tries to take all the complicated aspects of taking data from tide gauges and videos from WebCOOS cameras and merging them in time and making really nice visualizations to let you watch video from the camera and data from the tide gauge progress through time simultaneously. So the idea of the software package is that it takes all that complicated stuff and it abstracts it away from you. And so you just kind of have to put in a few of these high level variable and pieces of information, and you should be able to get a nice time synchronized visualization. So Theo, if you go to the next slide, and then hopefully if you click on the two videos that pop up, I hope this will work, but excellent. These are the types of videos that the software package can give you. So these are from the left is the Charleston tide gauge, and the right is Georgetown, I believe, South Carolina. And the idea is that you can see, like I said, you can see the water level moving up and down in the time series on the bottom, but hopefully more powerfully, you can see on the top, like what those water levels actually look like on the ground. What does it actually mean to be in a major flooding stage? What does that mean for that location? What does it mean to be in a minor flood stage? That sort of thing. So the hope is that, this makes it sort of more boots on the ground. What do these water levels actually look like? Okay, so Theo, you can go to the next slide. Thanks for sort of making those play on a loop like that. I appreciate that. So like I said, this is just a quick overview here. I think we're still working on a few things in this regard. Like I said, we're hoping to get more WebCOOS cameras deployed near tide gauges so that we can do these types of visualizations in other places, right? We can technically use this software tool to do these sort of synchronizations anywhere, but really it's the most meaningful if the camera and the tide gauge are really closely co-located so that we can really see what those water levels look like on the ground. We're also working on integrating some of these video products with other co-ops products. So like co-ops provides top 10 floods at a lot of their tide gauges, and so it would be really cool if you could see this list of top 10 floods, but then you could also click and see a video of some of these if they occurred, you know, when a WebCOOS camera was deployed. So things like that are also ongoing. And then another big aspect of this work has been sort of automated separation of different views. So this will probably be talked about more after me as well, but a lot of WebCOOS cameras and webcams in general pan, tilt, and zoom across multiple different views. And that's really nice for some things, but for the videos that I just showed you, that's really not nice if we're just trying to look at one specific scene. And so we sort of have some built-in machine learning algorithms in that code that I showed you that help you sort of separate those different views, so you're only pulling the one that you want. Though there's certainly still room to sort of improve those things and work on that automated system. So I'll leave it at that. I'm happy to take any questions at the end, and I'll pass it to the next speaker. Thanks.
Great, thanks, Matt. Really interesting stuff there. Now we'll pass it over to Alex Pang of UC Santa Cruz to talk about some shoreline and runup applications with web cameras. Alex?
Hey, good morning, or good afternoon, as the case may be. I'm Alex Pang. I work with Joe Long on shoreline detection and shoreline change. My background is in computer science. My work with the WebCOOS project involves rip current detections and more recently on shoreline detections, both of them using machine learning algorithms. So what I wanted to do today is talk about shoreline detection and possible uses of shoreline detection. Next slide, please. Okay, so this gives you an overview of the schematic on the upper right. It just kind of gives you the architecture of the machine learning algorithm that we use for shoreline detection. Typically, you would have a bunch of images that label to indicate where the shoreline is, and then collect a bunch of those, feed that to your machine learning algorithm, and once it's trained, it should be able to detect the shoreline when given a new image that it hasn't seen before. The first thing we had to do was define what the shoreline was, and what we use that seems to make sense and agreement from the literature that we've seen was to define shoreline as the boundary between the water and the land. So that's what we went with. So in labeling the data, that's sort of the definition that we followed. We use some tools. The primary tool that we used for labeling was SAM, which is Segment Anything package. To give you an indication of so once the model is trained, it's pretty fast. This short video on the bottom right kind of shows you the green. I'm not sure if it's visible, but there's a green shoreline that's kind of hugging the water as it moves in and out on the beach. It's pretty inexpensive in the sense that you could run 2 streaming feeds from any WebCOOS camera. And this one we're running off an old desktop, which has a 3080 GPU, which is probably about, GPU was introduced about 5 years ago, so it's fairly dated in terms of computer years. Anyway, so next slide. So one of the applications with real-time shoreline detection is that you could estimate the sea state. So rather than having the camera point at the ocean and kind of look at the heights of the waves and so on, some of the cameras on WebCOOS are pointed along the shore. So we could detect the shorelines, and then based on the movement of the shoreline, kind of go backwards and estimate what the sea state looks like. So that's our hypothesis to see if we could do that. So we started off with some rating of what the sea state is, and this from the World Meteorological Organization. The primary parameters are significant wave height, peak period, and I think the other thing that's relevant is the mean wave direction, because depending on the mean wave direction and the orientation of the beach, the wave could be coming in directly into the beach or it could be shadowed. And then the other factors that we think would be important would be the tide and uh, uh, possibly the geometry or the bathymetry of the intertidal zone. Next slide, please. Okay. So the study area that we chose was Jeanette's Pier. There's two cameras there. We chose the one that's facing north. So the top right image shows you the location of the camera. The bottom right image shows you a view from that camera. This location was a good study area. It's primarily, the beach is primarily facing northeast. It's got there's no obstruction offshore, so it's got a good exposure from any ocean swell. And the beach is kind of fairly representative of beaches that we see along the East Coast. Next slide, please. Okay, so what we did was we selected two different dates, and it happened to be back-to-back dates, where the sea states from the NOAA recordings from a buoy offshore would indicate either a mild day or a rougher day. So on August 27 of 2024, this was a fairly mild day. And on the bottom row, we can see the red curve indicating where the shoreline is for that particular frame of the video stream. And on the top row, what we've done is collected a bunch of shorelines for a time period, and we plotted the essentially a box plot of those curves. Sorry about that. So if you're familiar with box plots, the top row are basically called curve box plots, and they're basically equivalent of the regular box plot. So you see the mean and median curves, the outliers, and the interquartile range. So what we see on the upper row is that for these different time frames, the interquartile range and the outliers are pretty close to the median curve. And as you go from left to right, the tide was coming up, and so you see a little bit of variability on the curve box plots on the right, but overall, the variability of the curves were pretty tight. So this was our hypothesis. This kind of was good in the sense that our hypothesis was that on a fairly calm day, all the shoreline curves should be fairly close to the median curve. Next slide, please. Okay, so this was the day before. I think there's a typo here. This should be August 26, 2024, if I'm not mistaken. On this particular day, the mean wave direction was mainly east-northeast, so it was kind of more onshore, and there's the sea state was a little bit higher. I forgot what the actual, I think it was about 0.63 was the significant wave height, or closer to 1 meter. Anyway, what you can see primarily from the top row is that the variability of the curve box plot is way more than what we saw the previous day, or on the 27th rather. So this was a good result in the sense that there's some obvious correlation between the variability of this curve box plots with the sea state. Obviously, these are preliminary results, and we need to study this further. Next slide, please. Okay, so I think a couple of days or about a week ago, Theo mentioned that, hey, check out the camera at Janet's Pier. And since we've been looking at that, there's some flooding and some significant wave action going on. On the top left is an operational an algorithm that's running operationally on a couple of sites. This is Joe Long's group work, where the blue line on the beach that's kind of close to the sand dunes is the baseline, and the red curve is the detected shoreline from a time average image. This was an image that was generated automatically when the shoreline passed the baseline. In this case, since it's set up to be along the dune, this kind of indicated a run up or an overwash. And on the middle of the top row is a particular frame around 1 o'clock that day, where it corresponded to the high tide on the bottom. That's kind of indicated on the bottom image. So the predicted tide around 1 o'clock was supposed to be around 2 feet. The mean low watermark, I believe, from the tide gauge was indicating 4.5 feet, so quite a bit more than the predicted level. And on the top right is the corresponding curve box plot. And again, it's we didn't show the extent of the oh, I'm sorry. Here we're just showing the median curve as well as the two outlying curves, the kind of the high and the low, as well as the baseline. And this kind of indicates similar thing as the current method that uses Timex. So I'd like to wrap this up. So next slide, please. So we just saw one possible application of real-time shoreline detection. This is trying to estimate the sea state from the observed shorelines. So a little bit indirect, but it's possible. We can also use the real-time shoreline detection, I think, to reconstruct the intertidal bathymetry by since you have the position of the shoreline and the tidal information, you know the height and as well as the XY positions of the shoreline, you can be able to reconstruct the bathymetry as well as estimate on the beach profile, at least for the intertidal zone. I'm excited to hear from the audience for other possible applications of real-time shoreline detection. Thank you.
Thanks, Alex. Really interesting to see that day-to-day comparison as well. All right, with that, we'll move to the next group in the WebCOOS team. So this is Dwayne Porter and Jeremy Cawthorn of the University of South Carolina, and they will speak on some community-supported environmental monitoring and reporting in South Carolina, how they've used data and science with that community. Go ahead, guys.
Okay, thank you, Theo, and good day, folks. And Jeremy and I are going to tag team this a bit. And to set the stage, so across South Carolina, we have a very robust network of communities, community leaders, faith-based institutions, and residents in our underserved communities who literally got fed up with inaction in their communities and began to recognize that in order to address issues that were impacting their quality of life, they had to take things into their own hands. And way too often, our community leaders and members would go to city council, county council, etc., and they would use emotions to try to get their point across. They would stand in front of the elected officials and they would scream, cry, curse, etc. And eventually there's a realization that that only gets them so far. But when communities start to bring sound science and data to the table, they have learned that it can make a profound difference in beginning to address these issues. And I'll walk through a quick example, or Jeremy and I will walk through a quick example. So next slide, please. So one of the communities with which we have the privilege of engaging is the Rosemount community. And it is one of the forgotten communities in the neck area of Charleston that is sandwiched between the Ashley River on the western side and the infrastructure associated with the Port of Charleston on the eastern side. And with a changing climate and with recent enhancements to the Port of Charleston, the Rosemount community has experienced an increase in flooding, whether it's sunny day flooding, it's storm associated flooding, or it's flooding that is exacerbated by the infrastructure that lines the eastern side. And community members have gone to city council, county council, etc., and they were told time and time again that the flooding was not occurring. And that's when the community decided, well, it's time to prove that the flooding occurs. And this is a perfect example. Our great blue heron, which is one of the local favorite birds, that utilizes the flooded community park that, according to government officials, doesn't flood. So this was the first example of the power of the picture, bringing WebCOOS into the community. And next slide, please. And working through a number of collaborations, including WebCOOS, our what used to be our EJ Strong initiative that we've had to recently rename, and the University of South Carolina, the College of Charleston, the Medical University of South Carolina, Department of Environmental Services, the Low Country Alliance for Model Communities, the Charleston Community Research to Action Board. The latter two are grassroots efforts. One focuses on advocacy, and SECOORA focuses on science and monitoring. The community comes together and self-identifies what are the issues of concern. And for the Rosemount community, it was not only the flooding, but also concerns with air quality that impact their quality of life. So the community came together and, working with partners and collaborators, established the Rosemount Community Environmental Monitoring and Reporting System. Monitoring that doesn't lead to reporting is only going half the distance. And so the community now has WebCOOS cameras in place. We have air quality monitors in place. We have a water level station in place. So the community are collecting the data that are documenting the environmental considerations that are impacting their quality of life. And it's done in such a way that, you know, they're not going to deal with parachuting scientists to come in and say, well, I'm going to solve this problem for you, get my publication out of it, and then leave. They want to ensure that their efforts are sustainable. And working through WebCOOS and all of our partners, we've demonstrated that. The community has demonstrated the power. And getting into some of the nuts and bolts, Jeremy, how about I'll turn it over to you?
All right. Yep, I'm Jeremy Cothran. I work with Dwayne at the University of South Carolina. I'm a software developer and electrical computer engineering background, so electronics and that kind of stuff too. Dwayne originally got me involved with the Rosemount community with in regards to air quality, and then since they were putting air sensors to measure kind of particulate matter 2.5 levels, I was kind of tasked with building up like a system that could support so up to like an amp of power to like a low wattage device. And then so we kind of tacked on the cameras with the WebCOOS and so next slide, Theo. What yeah. So that this slide on the left is the left is one of the stations that we put up on a post there. It's that original system was a Raspberry Pi with a camera hooked up to a rechargeable battery and solar panel. I can provide information on that kind of custom setup. I added another slide, but since then I've moved on to trail cams. Trail cams, if you're only taking pictures once every 10 minutes or 15 minutes, you don't need like a high frequency video type capacity. Trail cams are probably the way to go. The ones I've gone with recently have been the Spartan Go Live 2 camera brand with a small solar panel. It has included rechargeable batteries, so that whole setup is at less than $500, and then about $200 a year for a data plan. So that can get you an email back photos at your frequency, and that one also has like a wider camera view, and you can if you're manual, you can turn on live if you want to get live video, and if there's a storm coming through, and since it has cellular, even if the home or location loses local power, it's not really using it's just off a solar thing. You got your power kind of taken care of, and your connectivity taken care of through cellular. So so in my mind, a lot of the stuff is about if a storm event comes up like a hurricane, like we have, if we do lose power or connectivity at the home location, like I'd still like to be able to get data back or pictures back, even in the storm, the storm events that might disrupt your power or connectivity. So, but yeah, so the trail cams are kind of the way to go. And again, feel free to contact me in regards to those setups. I think I put a link in one of the later slides, but this slide on the right hand side, it shows is a link to another paper that another researcher did from that location. That the picture on the left is pointing out across to a park area, open park area, and in that Rosemont neighborhood, a lot of those, it's an older neighborhood, and that neighborhood was kind of cut in half by the interstate a long time ago. And unfortunately, they put a sound wall in, and the sound wall creates a drainage issue into the neighborhood as it goes into the marsh, so the neighborhood's kind of sandwiched in between the interstate, which drains into it, and then the marsh on the other side of it. So it's kind of got it from both sides. And so our project is kind of with the water level also in the creek nearby, or the estuary nearby, is also trying to help differentiate between precipitation-based flooding and sea rise or any kind of ocean-based flooding. But yeah, the pictures on the right-hand side are from another person that used the flooding images, or this is more precipitation-based flooding from a rain event, where to train a model like Alex was talking about. The SAM model, and that's a very good model for doing segmentation of images to separate the part of the image that's flooded versus the part of the dry part of the image. And so the white areas in there kind of show the white and black areas, and those little sub pictures show different performance of models as they detect what it thinks are flooded parts of the image versus not parts of flooded images. And so essentially these, like any of these kind of cameras or setups can be used to kind of have more custom training sets, or more training images or videos, images in this case, to train a model to kind of detect what the phenomena you're looking for in the image. Next slide, please. And yeah, this is a backyard the back porch camera off of Lavinia, who lives in the cul-de-sac on the other side of the street, facing the kind of the estuary or marsh there. And the images on the right are personal images that she took, and so the community goes out and usually takes images of these kinds of precipitation or storm-related kind of flooding events. Most of the houses in this area at the cul-de-sac are raised houses, so they're 8 or 9 feet off the ground. And the images on the left, the top left is no flooding from October 2nd, and Dwayne talks about that being the kudzu marsh. That camera points into the kind of a very wooded area, a brief area, and then it's a creek up past that. But yeah, it's right beside the estuary there. And then the one that says December 17th, 2023 is, I think, also probably a precipitation related. We had probably 20 inches of rain during that event that affected Georgetown as well, just up the coast as well. So in the image also, there's a fence there on the right hand side, which gives you a little bit of a vertical indicator to kind of help measure the kind of level to some degree. a lot of times with the home locations, we do run into issues with, we initially had one on the front, like that was showing images like the one with the truck in it, but the homeowner beside them didn't want to be in the image, so we moved it to the back porch. So there was always kind of issues of privacy, and we talk about masking off parts of the image. We've done that with some other cameras and WebCOOS as far as creating just privacy masks so that people or things that we don't want to include in the image are kind of masked off. And I think that's about all I had to say on it. The homeowners, the people in the community are kind of, you go back to them a lot of times to kind of repeat about having documentation and about these cameras. They're taking images every 10 minutes constantly, are able to provide a timeline. So if there's a precipitation related event like this one back in December 2023, there's storm drains there. Sometimes they aren't cleared out, so the drainage will be slower than it needs to be. And so it's kind of a way for the community to say, hey, even though this event happened 2 days ago, we're still dealing with consequences of the flooding. We're having to use our own sump pumps and stuff like that to push the water into the estuary because the storm drains are blocked. And so this kind of essentially gives them documentation of when the flooding occurred and how long it stayed around for as far as drainage or follow-up issues related to that as well. So yeah, it acts as documentation for those communities. That's all. Thanks.
Okay, next slide, please. And to really personalize this, so Jeremy referenced the camera on Lavinia's house, and the other camera overlooking the field that floods is on Miss Cora's house. Last weekend, we had a stalled cold front along our coast, and we had the impact of what was Storm Jerry. And they came together, and we had, in Georgetown, we had 14 inches of rain over the course of the day, and we had not quite as much, but a significant amount in the Rosemount area. Last Monday night, we had a community meeting, and Miss Lavinia was there with her pictures to show the city of Charleston officials the impact that was taking place with the flooding in their backyard there. So once again, just the power of the picture. So as evidenced by the fact that WebCat has expanded into WebCOOS across the Southeast and now is national, the approach that we've taken is geographically and thematically transferable. So we can work with communities throughout South Carolina, throughout the Southeast, and take this approach and work with the communities to allow them to identify the issues and the data that they need. And now we're working, as I pointed out, to integrate additional environmental monitoring components, whether it's air quality, water level, water quality. We're working with another community down the road here that is concerned with both flooding and the impact of fumes from controlled burns in our one and only national park in South Carolina. So the communities are using the data and information to empower themselves. So rather than using emotions, they're using the data and sound science to make noise, to steal a comment from one of our favorite community members, Mr. Herbert Maybank. And with that, Theo, I'll turn it back over to you.
All right. Thank you, Dwayne and Jeremy. Yeah, it's great to see the application of WebCOOS and the imagery that can come with it and how it's useful to community members. So with that, heard from from Matt and then from Alex and Dwayne and Jeremy on different applications of WebCOOS related to coastal flooding. I'd like to thank the speakers again, and then thank everyone in the audience as well for listening. Here on this slide, we have some different ways to contact us, whether that's to the general WebCOOS inbox, webcoos@SECOORA.org, myself, Theo@SECOORA.org, or other members of the project team whose emails are listed here on the slide. So thanks, everybody. I'll pass it back to Emily for any question and answer time we have.
All right, so we actually already have one question in the chat, and I believe this question was for Matt at the very beginning. Can this, which I'm assuming is the program you were discussing, work with the co-op's model output?
Yeah, great question. I'm sorry, I don't know how to access the chat and whatever this is. Not directly right now, but that's definitely a feature that would be really cool to integrate. So right now it's just sort of, you can just punch in whatever tide gauge ID you want. You can punch in whatever WebCOOS camera name you want, products, time frame, press go, and it will make you one of those visualizations. And there's a couple other types of visualizations that you can make too, depending on what options that you select. I think it's a good point. Sort of integrating model output into that could be another nice source of time series data to include. So I'll keep that in mind. Thanks for the comment.
All right, so we do have another question from Ellen Prager, and I'm just going to be going in order down the line. So if you do have a question that's specific to a speaker, make sure to put in what speaker you want me to ask that to. So I believe that this is for Dwayne, but I think anyone could probably reply after Dwayne. How do communities access data and understand what it means to them?
I'll give you a couple. I'll give you two examples. So one of which we're working through, again, SECOORA, the Charleston Community Research to Action Board, that has established their own data management committee that includes residents of the engaged communities for the development of a data portal. So it provides access not only to residents, but to the city, to the county, to engineers that are working on flood issues in the communities. In terms of providing training so that the communities and community members understand how to utilize the data and what the data are telling them. Two quick examples, one of which, again, working through SECOORA, we're providing training to community members so that they can begin to do analysis themselves because they want to do it. The second is a really cool initiative we have in Lower Richland County called the Community Earning and Learning Initiative. And again, this is an area that flooding is a major concern, addressing quality of life issues. And so we partnered with Lower Richland High School, secured funding from our General Assembly, and high school students are being trained how to install and maintain monitoring assets, how to access the data, and how to analyze the data and provide results back to their communities. So literally, we are engaging in the training and interpretation from K to grade across our communities.
Thanks, Dwayne. Did any of the other speakers have anything to add to that, or could I move on to the next question?
I would say,
All right.
in general, that WebCOOS cameras and the imagery that they are recording are available at webcoos.org. You can go click on the map and find the camera of interest, or go to webcoos.org/cameras and find the one that you're interested in to find video and still imagery on there as well.
All right, so Dave Jones noted that he really liked the time lapse and data showing through Matt's visualization, and his question was, is the Python script that Matt showed available to improve the visualization of the data and graph?
Yeah, thanks, Dave. And I figured out how to access the chat. So you put another one sort of at the bottom also. So I'll answer both of these together. So yep, the Python script, it's all open source. The QR codes that I put on the slide there will take you right to the GitHub repos. I welcome, you can take the code, do whatever you want with it, take it on your own. If you want to sort of work collaboratively, I welcome. GitHub makes that easy to do. So if you want to improve how the graph is made, or just give me feedback or anything like that, send me an email, do whatever works for you. So yeah, totally all open source, super open to collaboration. And then yeah, your other question at the bottom, or your next question in the chat, talking about how the different flood reference levels being relative to popular locations is really important. And if we could place a link in the graph when those floods those flood levels are reached, you know, that would be super cool. That kind of gets to the fact that it's not a real-time operational product yet right now. I think that would be really, really neat if we could sort of have this operating in real time. Right now, this is really a sort of a post hoc, after the fact, take the data and make the visualizations. You know, and a big part of that is the pan, tilt, zoom aspect of these cameras. The you know, making sort of AI ML models to separate the views is pretty time consuming. Hopefully, once you do that, you can have something that operates pretty quickly, and maybe, you know, Alex touched on this, maybe quickly enough to operate on the fly. I'm not sure. That would be something that we can investigate. But it would be really cool to have this working in an operational sense to do that. I will say also that another type of visualization that you can make is actually, you can say, give me images at X flood level, plus or minus whatever threshold, and it will pull a bunch of images that were taken during that water level, so you can get a sense of, at that specific water level, what you want. So that's still a sort of a post hoc, not real time application, but that is an option as well. Thanks for the questions.
All right, so the next question is from Ryan Grech, and this question could probably apply to all of you, but Theo might be the best one to answer it first. How are the communities that have a web camera installed chosen and receive training and other resources?
So sure, I can take a first cut at that and maybe pass it over to Dwayne to speak more specifically about any of the communities that he works with. But in general, you know, in the current phase of WebCOOS, as we expand nationwide, we're working with other IU's regional associations, so places like, or organizations like MARICOOS or SECOORA or GLOSS across the country to have more of a feel of regional priorities and areas of interest and applications of interest within their region. And then working with, you know, more local partners who understand the needs in the areas of interest in places that would be best candidates for monitoring in particular localities. Yeah, Dwayne, do you want to add anything to that in terms of the work that you all have done in various communities in South Carolina?
Going back to my earlier comment about the fact that we had this very robust environmental justice network across South Carolina, the communities that have begun to come together themselves, then they come to us and engage with us, and then we move forward. We have a standing meeting every Tuesday at 1:30 with our EJ Hub network across the state, and it's expanding. And so more and more communities, as they see what other communities are doing, and the other communities are providing guidance to those communities that aren't yet using sound science to address issues, our pool of interested communities just continues to grow.
Thanks, Dwayne. I was going to add one more thing too, that there's kind of like a trade-off between, or potential trade-off, I guess, between utility and feasibility. For example, there could be, you know, an area or a community that has a real need, but installing a camera in that location is more or less feasible. So there can be kind of, you know, ideally they both sync up. It'd be feasible and very useful. Sometimes there can be a trade-off there as well, if there's, you know, not infrastructure to make a successful installation in that area. That's another consideration.
Okay, so the next question I think would be best for Theo again. This question is referring to the cameras that are listed out on the WebCOOS website. Are the cameras that are currently archived going to go live in the future? And are you planning any new cameras that might go online soon?
So for the archived ones, I would say most of those, there are not specific plans to make them live in the future. Those are maybe things from the WebCat project that were deployed for a certain period of time and are not anymore. There are a couple, I think, that are listed as archive on the map that are you know, just temporarily down, but would come back, but generally archive ones would not. And we are definitely in the process of adding new cameras. We just added a new one in SECOORA region in California, a week or two ago, and we are hoping to get one in the Great Lakes region with Gloss online here very shortly. So we're definitely working to add new cameras now and into the future.
Great. So the next question, Alex, you kind of answered it in the chat, but I thought I would bring it forward in case anyone had the same question as well. This question is referring to the automated shoreline detection system. This question asker said that the system seems to focus on the white water line closest to the beach, and wondered how that estimate related to the wet beach expansion.
So I'm not sure if my text response answered Philip's question. If not, I could try to elaborate. But we do have another ML model that was trained on a different set of labeled data that was using a different shoreline definition that's based on the web tribe boundary. So I guess it might depend. And again, this is my background is in coastal science, so I definitely would welcome suggestions and comments. So we tried to look at both ways of defining what the shoreline was. And indeed, there are some ambiguities for both definitions as well. So for example, on a very dynamic day, you could have a wave coming in and the water, as the first wave starts to recede, the next wave comes in. Where do you put the shoreline? Do you put it at the next incoming wave, or do you put it at the boundary of the earlier receding wave? So sometimes the algorithm gets confused when the first receding wave level is almost undetectable visually by the camera resolution. So yeah, I'm open to suggestions on that, which would be better to use, which definition is better to use.
All right, so the next question is, have you all had success integrating existing live surf forecast cameras into WebCOOS? Theo, probably.
Probably. We do have some cameras in WebCOOS that we call cameras of opportunity. So some of the cameras in our network are not ones that we installed ourselves, but were rather existing cameras, which I think are similar to what this question is asking, where someone else has installed them, someone else is maintaining them, and they are allowing us to access the feed and store the imagery and become part of WebCOOS that way. So that is, in that regard, yeah, that's what we have done. We've taken existing cameras and added them to WebCOOS. Yeah, I would say not all of them. Like there are, I don't know, thousands of cameras probably that exist, and they're not all WebCOOS. And there are not plans to bring all of those cameras into WebCOOS.
So this next question is from Dave Jones, who runs Storm Center Communications. And he was wondering if there was a way to proactively identify which cameras are observing flooding or higher than average water levels in real time for emergency managers to use in briefings.
I'll take a first stab at it, and maybe Matt can help. So one thing that we've done with partners at NOAA is added a layer for WebCOOS cameras into the NOAA's coastal inundation dashboard. And that map, or their map on that feature, does have kind of like a pinging, like red circle over areas that are experiencing flooding. So if you were on the coastal inundation dashboard and saw that the NOAA station was pinging red, was showing to be in a flooding state, and there was a WebCOOS camera nearby, you click on the link, go to the WebCOOS camera, and see what it was doing. That's probably the closest thing I can think of. Matt, do you want to add anything to that?
Yeah, it's a good start. It's a really good. It would be really cool. I think, you know, it would also be really hard. And I think, Theo, what you said is probably the closest that we're at right now. You know, to have something that was more automated, you know, something that was like an actual WebCOOS product, like the camera sends you a flag when the water level exceeds some level. You know, that would require, you know, real world referencing elevations in the image, and then having some sort of imagery flag video algorithm that can flag when the water gets vertically above that or not, which would have all sorts of interesting image processing implications of knowing what's vertical and not knowing what's vertical and all that sort of stuff. So I don't think we're close to that, but like Theo said, you know, we have work to integrate the WebCOOS cameras with coastal inundation dashboard. And I know there was another question in the chat, or a comment at least, about being able to see these in coastal inundation dashboard. And so I think that, you know, when you see those tide gauges pinging because they're close to a high tide flood event and there's a camera nearby, I think that that's probably a decent indication that you're going to have flooding nearby, and that might be the best that we can get for now, at least. But definitely really cool research avenues to consider.
So if I may add to that, there are some algorithms that are currently being run on WebCOOS sites. So there's a couple of sites that's running rip current detection. There's a couple of sites running shoreline detection that I shared with you earlier from Joe's group work. Jeremy also has a kind of more general alert system that is created. So it's not, I think we have the pieces, but it's not all integrated quite yet. But potentially you could have, depending on the application problem. So let's say if you're interested in coastal flooding, you could look at overtoppings based on detection from Joe's algorithm, for example, and then have an alert system set up. One possible way to kind of do that. So I think there's potential for addressing that need.
All right, well, thank you everyone for the great questions. This was a great discussion, and thank you to all of our speakers for providing all of this information. Here's the email list again, if you wanted to reach out to any of the speakers to make connections. As a reminder, this will be available on SECOORA's YouTube channel, hopefully by the end of the day, and we will also have it on our website. So thank you again for everyone that joined today, and I hope to see you at the next one.
Thanks.